So now we're kind of through like the intro part of chapter 6, and now we're going to kind of go back to something that we already covered, but then in more detail. So 6.3 part 2 is trigonometric function values of any angle, and we're going to be specifically looking at some of our special angles that we already talked about. But before we can go there, the first thing I want you to do is use your calculator, make sure it's in degrees, and I want you to plug these four function values in. So the sine of 30, the sine of 150, the sine of 210, and the sine of 330. So go. Pause the video. Okay, so sine of 30. Actually, I'll just pause it. I'll type them all in. The magic of the pause button. So when you plug these all in, I hope you looked at them and went, well, wait a minute. They're all 0.5. So it didn't matter whether you plugged in sine of 30, sine of 150, sine of 210, or sine of 330. They all came out to 0.5. The only difference being two of them were positive 0.5 and two of them were negative 0.5. So what I want you to do now is draw these four angles in standard position, meaning reading them from the x-axis counterclockwise. So 30 degrees would be 30 degrees in the first quadrant. 150 degrees, if you were to draw 150 degrees, how would you do that? Like, how would you figure out where it is? Well, if I know that half of a rotation is 180 degrees, 150 degrees is what? It's 30 degrees less than 180. What about 210? When I go to figure out where 210 is in space, I'm like, okay, it's more than 180. How much more? Oh, look at that. 30 degrees more. Are you starting to see a pattern? 330 degrees is in the fourth quadrant. Going all the way around would be 360 degrees. But 330 degrees is 30 degrees less than 360 degrees. So what do we notice? We notice that every single one of these angles makes an angle of 30 degrees with the x-axis, which means that they all have the same value. Why? Because if I was to draw my special triangle, remember 30, 60, 90 was a 1, 2, root 3 triangle. The 1 would go opposite the 30 for every single one of these. Opposite is 1. Over here it would be negative 1. And then my across from my 90 is always my 2. And the radius is always positive. So in the first quadrant, opposite to hypotenuse, or y to r, is a half. In the second quadrant, with an angle of 30 degrees, my opposite is 1, my hypotenuse is 2, a half. When I get to quadrant 3 and 4, the only difference is that the y is in a negative direction. So all of a sudden it's negative a half for sine of 210 and sine of 330 degrees. So what we're going to be exploring here is the fact that we already learned that the sine of 30 degrees is a half, but that 30 degrees can be a triangle drawn in every single quadrant. And then coterminally as well, you could go all the way around the circle once or twice to get to these places as well. So this 30 degrees, this special angle, is called the, well, for this example, is the reference angle that was made with the x-axis for 30, 150, 210, and 330. And the reference angle is the thing that we use to draw our triangles. So the next thing we're going to practice is purely figuring out reference angles. So if you notice, we kind of did a pattern here. In quadrant 1, the reference angle is the angle. In quadrant 2, the reference angle we found by doing 180 minus the angle. In quadrant 3, the reference angle was the angle minus 180. Right? So 210 minus 180. And in quadrant 4, you can find the reference angle by doing 360 degrees minus the angle. Now I have that all written in this chart here, but just sometimes it's easier to see in the picture. So I've got an angle in each of the quadrants, and I want you to figure out what's the reference angle. So for this one, you're in quadrant 1, so 60 degrees would be the reference angle. For this one, you're in quadrant 2, so to find the reference angle, you would do, oh sorry, this one you're in quadrant 2. So to find the reference angle, you would do 180 minus 115, which would give you 180 minus 115 gives you 65 degrees, right? So this angle would be 65 less than 180 in quadrant 2. This one, to find it, you would do 185 minus the angle, or sorry, minus 180, which give you 5 degrees, which means that this angle is 5 degrees more than 180 in quadrant 3. And then lastly, this one, to find the reference angle, we would do 360 minus 300, which would give us a reference angle of 60 degrees, which means if I was to draw it, it would be in quadrant 4, and it would make an angle of 60 degrees with the x-axis. So now what we're going to do is put this all together. So using the reference angle, we're going to be able to find exact values of angles in all 4 quadrants. Here we go. So this is the first thing that your homework assignment will be on, which is exact function values of special triangles. What I want you to do is find the reference angle, draw the special triangle in the correct quadrant, and then check the signs on x and y, and then find the exact value. So example number 1. Find the reference angle and the exact function value if it exists. 300 degrees. So the first thing I want to do is figure out what the reference angle would be. Well, 300 degrees is in quadrant 4. So to find the reference angle, I'm going to do 360 minus 300 and get a reference angle of 60 degrees, which means this is 60 degrees in here. So step 1, I shouldn't have hidden the steps, find the reference angle, done. Step number 2, now that I know the reference angle, it's always going to correspond to a special triangle. So this is going to be my 30, 60, 90 triangle. The 1 goes across from the 30, the 2 is always the hypotenuse, so the radius, and then the root 3 goes across from the 60. Then you're going to check the signs on the x and the y values. In other words, this is a positive x direction, this is a negative y direction, and then the radius or hypotenuse is always positive. And then we're going to find the exact value. So the value of the sine of 300 is going to be opposite over hypotenuse, or y over r, so it's going to be negative root 3 over 2. Step 1, step 2 and 3, and then step 4. All right, maybe you feel ready to give this one a go, maybe you want to keep watching. So 225 degrees, which quadrant is that going to be in? Well, it's going to be in quadrant 4 because it's more than 180. So to find the reference angle, we're going to do 225 minus 180, which gives us 45 degrees. That tells me that the angle made with the x-axis will be 45 degrees, which makes it my 1, 1, root 2 triangle. Next step, I'm going to figure out, should anything be negative? Well, this is a negative x direction. This is a negative y direction. So both of them will be negative. So that I can now find the value of the tan of 225, which would be opposite over adjacent, or y over x, which would be negative 1 over negative 1, which would just simplify to positive 1. All right. Next one, cos of negative 120. Ooh, what quadrant are we in? Negative 120, I'm reading in a clockwise direction. So it's less than 180, so it's going to be somewhere in here. Now you would treat quadrant 3 like quadrant 4, where to find the reference angle, I'm actually going to do 180 minus 120, which is going to give me 60 degrees. So this is going to be 60 degrees again, which makes this 30. If you haven't paused the video yet, maybe pause now and label your special triangle. So 1, 2, root 3, negative 1, negative root 3. And then I'm finding the value of cos. So cos is adjacent over hypotenuse, or x over r. So it's going to be negative 1/2. And if you're kind of unsure and you're like, okay, I showed all my work because these questions will be worth 2 marks on a test, but you're not sure if you're right, do feel free to plug this into a calculator. Like if I plug in the cos of negative 120, then I do get negative 0.5, right? So it is a way of just making sure you did it right. I mean, this one I could have just done on my calculator. The key thing we're looking for is something like this first one, where if you plug in the sine of 300, it gives you some gross decimal. And so you could check that negative 0.8660 is the same as negative root 3 divided by 2. All right, last one. The last one, I chose this one because I hate these ones. I hate these 855s. what we have to do is find an angle coterminal to 855. So I'm going to find the smallest positive coterminal to 855, and I'm going to do that by subtracting rotations of 360. So if I subtract 360, I get 495. So 855 degrees minus 360 gives me 495. So now I'm going to do it again. So minus 360 gives me 135 degrees. So really, me telling you to find the cotan of 855 is the same as me telling you to find the cotan of 135. Now 135 I happen to know is in quadrant 2. So to find the reference angle, I'm going to do 180 minus 135, which is 45 degrees. So again, it's my 1, 1, root 2 triangle. And then I check for negatives. Positive y direction, positive radius, but negative x direction. And now cotan, right, if you ever have to look this up, cotan of theta is adjacent over opposite, or x over y. So it's going to be the negative 1 over 1, which simplifies to negative 1. Awesome. So now what I want you to be able to do is go and practice the questions that are just on these special angles.